Hey everyone, welcome back to this channel and I hope you are doing great. Today we are going to see the Tower of Hanoi problem, and the problem statement is we are given a 3 stack, that is the left, middle and right stack, and on the first stack we have given n number of disks over here, and our task is to place this all disk from A to C with some rule, and the rule is we cannot place the larger disk over the smaller disk, so this is invalid. Okay, so and our task is to minimize the number of move, and there is only one integer n, that is the number of disks is given, and we have to print the integer k, which is the minimum number of moves. After that we have to print k lines that describe the all moves. Okay, and the n is less than equal to 16. Okay, so first of all I am breaking this problem into this smaller one. So first of all I am taking the less value of n, that is the n equal to 1. So if I have n equal to 1 and I have one, that means I have one disk. So what should I do? I just place from this as a source to destination. Okay, and I can just print from A to C or A equal to 1, B equal to 2 and C equal to 3, and I can just print one move and 1 to 3. Okay, so let's analyze for n equal to 2. Okay, so let's say if I have given n equal to 2. Okay, so how can we place all this disk from A to C by do not violating the rule? That means we cannot place this and we cannot place in this configuration. Okay, so how can we place this all disk? So if we can using B as a auxiliary stack and A as a source and C as a destination, so what we can do? First of all we just place, let's say I call this one and this. First of all I can place my first disk from A to B, so the next configuration would be A, C and B. Okay, after that placing the first disk from A to B, I can simply place from my second disk from A to C. So my next configuration would be A, B and C. Okay, and after that I just have to place my first disk from B to C, A, B and C, that is my second, that is my first. So without violating any rule I can efficiently print my all disk from A to C. So what I am doing over here? Okay, first of all I am just placing my all disk except the last one, that is the placing my all n minus disk into the B by using C as a auxiliary. This will more clear when I am taking n equal to 3. So first let's say I am placing the first disk on B. After that when I got only one disk, so this is the configuration of a single disk problem, then I can simply place my second disk from A to C, and after that I just place my disk from A to B to C. Okay, so let's analyze one more time for n equal to 3. Okay, let's say if is n equal to 3, so what would be my initial configuration? 1, 2 and 3. This is 1, this is 2 and this is 3. At the first time let's say A, B, C. Okay, so what would be my approach? I just have to place my third disk in the bottom of C stack. So first of all I just have to remove this all n minus 1 disk. So what we can do? So first for n minus 1 disk my source would be A and my destination would be B. Okay, my destination would be B, and after that I just got only the third disk, and I place this disk from A to C. Okay, so if somehow we can A, B, C, if somehow we can place all this 1 and 2 disk on disk B, then I can simply place my third disk from A to C and after that this this would be my source, and this would be my destination, and we just have to place these two disks from source to destination, and this will become the for the n equal to 2 type problem. So we can see that if I calculate if I can calculate for n equal to 2, then I can also calculate for n equal to 3, and then I can also calculate for n equal to 3. Okay, so I can feel like I can solve this problem by recursive method by applying a base case for n equal to 1. Now let's analyze all the move for n equal to 3. Okay, so initially my configuration would be this. Okay, and in my first step I want my all n minus disk placed from 1 to b by using C as a auxiliary stack. Okay, after that I just place my third disk from A to C. Okay, and again I have 2 disks left over B, then again I want to place all the disks from B to C using A as auxiliary stack. Okay, so we have 3 steps. On step 1 I just have to move all n minus 1 disk from A to B using C as an auxiliary stack. After that we just place my bigger disk, that would be my nth disk from A to C, and after that the remaining n minus 1 disk I have to just place from B to C using A as a auxiliary stack. So for understanding what is auxiliary stack, we can see something like this. So we can assume this is a n equal to 2 type problem, and we just have to move from A to B and using C as a auxiliary. So what we can do, if we can do something like this, we just initially first place 1 from A to C. What we are doing, we just for this case n equal to 2, C would be my destination and B would be my auxiliary. So first of all we just place the first disk from onto the auxiliary, then my second disk into the destination. Again I am doing the same thing, my first disk into the auxiliary, that would on 1, and after that my second disk would be on my destination. Okay, this for this n equal to 2, this would be my source, and this would be my destination, and this would be my auxiliary. Okay, after that what I do, I just place the disk 1 from auxiliary to destination. So again I just place disk 1 from auxiliary to destination, A, B, C, that is 2, 1, and there is disk 3 is remaining on A. So I have completed my first step. Okay, where is my first step? I have completed my first step. That means I have placed all my n minus 1 disk from A to B. So what would be my next step? I just have to place my nth disk from A to C. Okay, from A to C, that is and after placing all my disk from A, my further configuration would be something like this. So I have completed step 1, I have completed step 2, then again on the third step, again this is the problem of n equal to 2, and at this time my source would be this and destination would be this, and I am using A as a auxiliary. Okay, so again for n equal to 2, what I am doing, I am just placing my disk 1 into the auxiliary. After that I am placing the disk 2 on the destination, and after that I place my disk from auxiliary to destination. That would be, I am placing my disk 1 on the auxiliary, and after that I am placing my disk 2 into the destination. And the next configuration, B have empty, 3 and 2, and A is 1. Okay, and after that I just placed the disk from A to C. Okay, so the A is also empty, B is also empty, and C have 3, 2, 1. And now I have moved all disk from A to C without violating any rule. Okay, so let's try to write pseudocode for this particular problem. So I have I am writing over here. This is my TOH function, and I have A, B, C and N. Initially A is 1, B is 2 and C is 3 and N is the number of disk. So I am just writing my base cases. If N is equal to 1, then I just have to print or store A to C. Okay, for N equal to 1, I just what I am doing from for N equal to 1, just A to C. Okay, so I can store in a vector or I can print A to C. Okay, after that I just call a recursive function that for n minus 1. And what would be my approach? I just placing my n minus 1 disk from A to B, that would be A to B using C as an auxiliary. This is the place of source, this is the place of destination, and this is the place of auxiliary. Okay, and after that after placing all the n minus 1 from A to B, what I have to do, I have to place my bigger what I have to do after placing all my disk from A to B, I have to place my largest, that means the if nth disk from A to C. So again I have to print A to C. So this is my first step, this would be my second step, and after that what would be my last step? I have to again move all my n minus 1 disk from B to C. Okay, so there is one more recursive call from B to C using A as a auxiliary. Okay, for all remaining n minus 1 disk. So this is my pseudocode for this problem. Okay, let's take a dry run for n equal to 3. Okay, so initially my TOH function is 1, 2, 3 and n is also 3. Okay, so let's take a dry run for n equal to 3. N is not equal to 1, then it will not go into the if condition, then it will call a recursive function. Okay, that is TOH for A to B, that means A to B using C as auxiliary, for which? For n minus 1, that would be 2. Okay, so again it will take a recursive call over here. Okay, TOH from A to B using C as auxiliary, that means A to B using C as auxiliary, and for n minus 1. Okay, and at this time we just got n is equal to 1, and we satisfy the base condition and we just print 1 A to C. So we just print A to C. Okay, after that, after completing this recursive call, I just have to print A to C for n equal to 2. Okay, so after that I just print A to C, that means A to 2. Okay, so what I am doing over here, first of all I am just taking the first disk and I am just placing from 1 to 3, that is 1 to 3, and after that I am taking the second disk, I am just placing from A to B, and that means A to 2. So my code is running fine, and after that again I am calling the next recursive call for this n equal to 2, then TOH, and at this time I have to place my at this time my source would be B and my destination would be C, and using A as auxiliary. So B as a source, C as a destination, and 1 as a auxiliary. Okay, for n equal, and for n minus 1, that would n is 1. Okay, then I have to print, I just satisfy the base condition, then I have to print A to C, that means 3 to 2. Now what I am doing over here, after placing my first disk on C, second disk on 2, I just have to again put my first disk from C to B, that will be the 3 to 2, and after that completing the all recursive function for n equal to 2, I just came back to the n equal to 3. Okay, and for n equal to 3 I have completed this recursive call, and after that I have to print A to C. So for this n equal to 3, A is 1, C is 3, so just I have to print A2, that means 1 to 3. So what I am doing over here, I am just, after just completing this step, that means I am just placing all my n minus 1 disk from A to B, I am just placing my largest disk, that is the third disk from A to C, and what I am doing over here. And in my next step I am just again calling the next recursive call, that means I am just placing all my n minus 1 disk from B to C using A as an auxiliary. Okay, so in my next recursive call, what I am doing, TOH from B to C using A as an auxiliary, that means from 2 to 3 using A as an auxiliary. Okay, for all n minus 1 disk, that will be n equal to 2. Okay, now again I am calling a recursive function, and at this time my recursive function would be A to B using C as auxiliary, that will be A to B using C as auxiliary for 1, and I satisfy the base condition, and after that I have to print or store A to C, that will be 2 to 1. Okay, so what I am doing over here, so after placing my third disk from A to C, I have to place disk 1 into the auxiliary, and what I am doing over here, that will be 2 to 1, and again after this recursive function I have to just print A to C, so I have to print A to what is my A, 2 to 3. So this is my second disk. After placing the auxiliary disk from B to A, I just have to place my second disk from B to C, that will be 2 to 3. Okay, and after that I again call a TOH, that will be my third step, again call my TOH function, that would be from B to C using A as auxiliary, that would be B to C using A as that would be B to C using A as auxiliary, and the n is for the n equal to 1. So again I satisfy the base condition, and I have to print what I have to print, A to C. So at this time, after placing 2 on the third stack, I just have to move stack 1 from 1 to 3, and just what I am doing over here. So after this my configuration would be something like the last step, and I am not violating any rule, so the dry run is complete for n equal to 3. Now coming to the time and space complexity, we can simply see that something like this. This is my n, and this will expanding something like this, and now my recursive call is grow exponentially, we can see that. Okay, for the initially for n minus 1, then we have to print, then again for n minus 1, and again for n minus 1, then also print, and again n minus 1. So it will grow exponentially, so the time complexity would be 2 to the power n, because we have 2 branches for each parent. Okay, and also for space complexity, we have the space complexity is also 2 to the power n, that is 2 to the power all n calling stacks. Now coming to the code part, the code part is pretty easy. If you understand the concept, then the code part is pretty easy. Okay, so first of all I am initializing the n and taking the input of n, and after that I am initializing a vector of pair for storing my path, and after that I call the TOH function for 1 2 3 and n and my answer vector. Okay, after that I just print out my size of the path, answer dot size. After that I have to print all my path, answer dot size I plus plus. Okay, and for each iteration I have to print cout answer I dot first answer I dot seccond. Okay, now I just have to write my TOH function. Okay, so int a, int b, int c, int n, and vector pair int ampersand of answer. Now first of all I am writing my base case, that is the n is, if n is equal 1, then I just have to push answer dot push back. What I have to push? A to C and return from there. And if n is not equal to 1, then I have to call my first step, that is TOH A to B using C as auxiliary for n minus 1. Okay, and after that I have to print my nth, I have to print for my nth disk from A to C. Okay, so again I have to, without print I have to store. So answer dot pushback, I have to print A and C, and after that I have to call my second recursive call, that is the step number 3. Okay, and at this time my source is B, my destination is C, and using A as a auxiliary. Okay, so my source is B, A is auxiliary, and C is destination for n minus 1 disk. Okay, now the code is complete. Just take a dry run, and this is working totally fine. For this, taking the first disk and move from A to C. After that, the second disk from 1 to B, A1 to 2, and again the first disk from 3 to 2, and the third disk from A to C. Okay, and again the first disk from 2 to 1, and the second disk from 2 to 3, and lastly the first disk from 1 to 3. Okay, now the code is working totally fine. Let's try to submit this code and let's see if it is accepted or not. Okay, and now it is accepted. And if you like this content and if you want more, then please subscribe to this channel and like this video and share among your friends. And if you have any query and if you have any doubt, then please reach out to me in the comment section. And thank you, bye bye, let's code.